Welcome everyone. I'm Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, AWS Discovery Day, Introduction to Prompt Engineering. Presenting today's topic is Harsh Sharma. Harsh is a dynamic corporate trainer with AAI champion with expertise in AWS, Python, and DevOps. Over the past 5 years, he's delivered immersive real-world training to professionals at Fortune 500 companies and leading universities, empowering them with modern cloud, AI, and automation skills on AWS. And he weaves together AWS services such as Lambda, SageMaker, EKS, CloudFormation, Terraform, Code Pipeline, and Code Build with advanced Python scripting and automation practices. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. In this session, we're going to break down the essentials of prompt engineering and explore how it can unlock the true potential of generative AI. You'll learn how well-crafted prompts drive more accurate, relevant, and efficient outcomes, whether you're in a business or a technical role. We'll also look at real-world use cases, best practices, and how AWS provides the tools and models to put prompt engineering into action for impactful AI solutions. Now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey Harsh, thank you so much for joining us today.
So thank you, Tracy, for the introduction, and welcome everybody to this masterclass. Today's masterclass is one of the AWS Discovery Day. This is on prompt engineering. I'm Harsh Sharma. I welcome you all in this session. I am an AAI working with Netcom Learning. I take trainings around AI, cloud computing, data science, machine learning, etc. I hold bunch of certifications around AWS. So today's topic is on generative AI. It is on prompt engineering. For us to understand what is generative AI and what is prompt engineering, we will kind of proceed with the journey starting from what is machine learning. This is not the primary topic for today, but I have 4 to 5 slides to explain you the conceptual part of machine learning, deep learning, and generative AI. And then we will spend most of our time around what prompt engineering is. So I'm sure if you are following up on IT trends, you must have heard of a tool named as ChatGPT or a tool named as Claude. Or from Google, there's a tool called as Gemini. Amazon Web Services has a tool called as Bedrock. They are very, very famous among all IT professionals and all the people who are not even IT professional, but do interact with their laptop, do stay active over internet. All of these tools are commonly referred as AI tool and specifically referred as generative AI tool. So what is this generative AI? What this technology is what we are going to focus on. The word prompt engineering is only and only related to generative AI. So for us to reach there, we have to cross certain steps. One of that step is machine learning. It is a very broader area of AI. And this particular area of AI focus on learning from data. But this primarily is able to create narrow AI. So what is narrow AI? I'm going to write a few examples and you will understand that why they are called as narrow AI. Let's say there is one system, one software-based system, an AI system, which can predict flight delays. Now, predicting flight delay is a very, very complicated use case. But do have use cases, we do have softwares which are able to do this. I will write another use case, which is like handwritten or handwriting recognition. So I can write something, as you can see, I am writing on this white screen, and a software can understand that this is P, this is R, this is E, and so on. Even if I write P like this, or I write P like this, or I write P like this, as far as it is following a pattern, that there's a straight line and there is a curve, it will be recognized. Now, if you notice, both of these system, point number one and point number two, are solving some complicated use case, but they are only solving a specific use case. The one which can predict flight delays cannot perform the task of recognizing handwritings. Forget about handwriting recognition. Even the system that can predict flight delays cannot estimate that based on the price of Apple today and in the last week, what will be the price of Apple tomorrow, which is a fairly easy task compared to predicting flight delays. So a very complex system cannot perform a very, very simpler task. And at the same time, any other system cannot perform any other task. So this is what usually we refer as narrow AI. In today's time, where we are standing is more commonly known as AGI, artificial general intelligence, not a narrow AI, more of a wide support AI. If you look at any of these tools here, ChatGPT, Claude, Gemini, and many more, you will notice that there's not a single use case which is only possible with them and it cannot do any other thing. Like if I ask you what you can do with ChatGPT, so everybody must be using it for multiple purposes and definitely different purposes. I, as a trainer, I use ChatGPT often to create PPTs, to create examples, to sometimes study when I'm upskilling into new topics. Somebody who is, let's say, a sales analyst is looking to use ChatGPT for understanding various sales conversation. Somebody who is in marketing may use it to generate marketing captions, etc. So they are not limited to specific tasks. The start of this entire discussion was around machine learning, which is very limited to specific tasks, often referred as narrow AI. If you go more deeper, if you go more advanced in this, there is something called as deep learning, which is useful, very much useful in the sense of image and voice recognition. If I simplify it, I would say it is that type of machine learning which uses neural network and it can work on complex data. Patterns are not very simply observable. They are hidden deep within the data. So we need complex mechanisms to handle such a complex data. Deep learning is one such complex mechanism. For example, why do we use it primarily in image or voice or text compared to machine learning, which was primarily working on numbers? Because images are not so easy to deal with. They have patterns in them very deeply rooted. For example, if you see this image on the right hand side, this one, you see it's primarily an image where dominant color is blue and there are many shades of blue. If you also notice, there is kind of a triangular convergence and divergence here. If you also notice another thing, there are multiple columns of ones and zeros. If you try to find out more patterns, you will see sometimes the shade of one is in different color, sometimes it is in different color. So more or less it is presenting so many informations. This is just a way of me to explain you what complex patterns looks like. Then there is a text somewhere. Then there is an artwork somewhere. And we need to use complex mechanisms, complex neural networks to extract patterns from them. That's what deep learning is. Now, that is all I wanted to talk about machine learning and deep learning. One more thing, machine learning is a subset of AI. So I would denote subset of AI. Deep learning is a subset of machine learning. And then finally, we have generative AI, which is a subset of deep learning. So a specific type of deep learning, a specific type of neural networks contribute in making what we commonly call as generative AI. Do we have any use cases of traditional AI, traditional machine learning and deep learning? We do have plenty of use cases like marketing. So we can use machine learning and deep learning for customer segmentation, dividing customers into different groups that these are high paying customers, these are low paying customers, etc. If you are using Amazon or if you're using Netflix or if you're using Google, you must realize that they are tailoring the content for your preference and providing you very personalized recommendation. If you open Amazon.com and you search for formal shirts, and even if I open Amazon.com and I search for formal shirts, you will get different results. I will get different results based on the pricing, based on the country, based on so many other factors. So personalized recommendation. If you open YouTube and if I open YouTube, we will get different results of videos on the homepage. Personalized recommendation. It is also useful in predicting churn. Churn is change of customers. So people who are customers or employees or anybody who is leaving the organization. Let's say I have been using Netflix for a long period of time. Now I think Netflix is not doing enough justice to me. I would switch to Amazon Prime. So this is a churn for Netflix. And organizations do spend so much of efforts on finding out and predicting these churn values before it occurs. Similarly, there are many more applications in other industries like finance. So if you notice your credit card transactions sometimes do get declined because there is a real-time fraud detection algorithm in use. It is also useful in algorithmic trading, stock market purchase and sales based on pattern. It is also useful in credit scoring model. So in different countries, there are different financial scores. For example, I live in India and in India, there's something called a CIBIL score. Similarly, in US and Australia and different countries, you must have some score which gives you a number that should you be granted a loan or not? Are you a trustworthy person or not? So it has its own range. Usually higher the number, better it is. Now that number is coming through a machine learning or deep learning based application. We have a lot of applications of machine learning in healthcare. Many of them are still in use, like medical image analysis. So there are plenty of types of medical images like MRIs, X-rays, brain tumor. Now I don't know what type of test image it is, CT scan, etc., etc. So many of them, ultrasound is another example. Many of these tests are using image analysis. And just like a professional doctor who can look at an image and analyze it and understand that this part of your organ is good and this part of your body is bad, we can also train an AI algorithm based on a lot of data to perform the same task. And there are plenty of such use cases already in use, already being consumed by healthcare industry. It is also useful in predictive diagnostics. So traditionally what happens is you face a symptom, you go to doctor, the doctor diagnose you and then tell you that no, there is no problem at all, or tells you that okay, there is a problem and these are the medications you should take. But what if, based on the genetical information, based on your lifestyle, based on the place you live, based on the food you consume, based on the amount of workout you do or you don't do, we can predict that you have a family history of diabetes and at approximately this age you are going to be diabetic, so it would be better if you consume less sugar from now onwards. That is predictive diagnostics before the symptoms show up. Similarly, if you are a sportsman and you have been facing minor or major pain in your elbow, a trained doctor can understand that your elbow joints may are not are may not okay. Let me repeat. Your elbow joints are not very strong and they need some treatment or they need some diagnostics, even if the symptoms are not showing up right now. And then there is plenty of AI technology which is working on personalized treatment plans. Not a regular treatment plan which will be followed by everybody, but rather something very, very specific to you. What diet you take. Are you a vegetarian or a non-vegetarian or a vegan? Are you having an active lifestyle or you are having a sedentary lifestyle? Do you have a family history of certain type of chronic diseases or not? Based on all of that, there can be a very personalized treatment plan. And there are plenty of AI softwares doing this. Now, that is all I wanted to talk about machine learning and deep learning. Nothing more than that. We will switch to something very different, which is commonly called as generative AI or Gen AI. What Gen AI is, if you notice all of my use cases earlier, predicting whether this person is going to be diabetic or not, predicting whether the transaction is fraudulent or not, predicting this particular customer will leave the organization or not. So there are usually few categories and I'm choosing between them. That is called as classification or segmenting the customers into different groups. That's called as clustering or predicting a continuous number, like what is going to be the life expectancy rate in US in 2050. So that's a continuous number. It cannot be a category. But we are not talking about generating novel, unique, new content. That's where the gap is, and that gap is fulfilled by generative AI. Now, this type of AI is responsible and capable to create new content. That new content can be conversations, basically text, or stories, images, videos, music, code, and whatnot, signals. That's not mentioned here, and many more type of modalities. Right. Movie is type of a video, but I would specifically add on here movie, which has a story, which has a cast. So it is a type of AI that can create new content And that is where tools like ChatGPT and DALI and Titan and Claude are gaining their fame. Before this, we did not have any technology which can actually understand my question, not data, question, and respond back with a new content for me. For example, I would take you to my ChatGPT website, my ChatGPT console, and show you what I'm highlighting. A minute. So this is the GPT tool. I am sure you have kind of used it, seen it, you're familiar with it. I'm not introducing the tool, it's just a platform where I can search something and get the response. Let me show you how is it different from traditional content analysis work. If let's say I want to read something about Easter or something about Christmas. So I would go on Google, I would say Christmas or history of Christmas. And I get ignore this part. This is generative AI, which is very, very recently introduced. I'm sure you're aware about it. But usually Google was known for presenting results which are already there in one or the other website. So there's a website called as Britannica.com, which talks about what is Christmas, its origin, definition, tradition, history, and facts. Wikipedia article. Then there is history.com, there is Vedantu.com, and there are hundreds of websites, maybe thousands of websites talking about the topic. If I say history of Christmas in a poem, do I have any? I have story behind the most famous Christmas poem of all. Okay. How a poem transformed Christmas into the festival holiday. Okay. So there are few results. Now let's say I specify history of Christmas in a poem written in the domain or with the words. Now I'm just trying to make it very unique, very specific. Now, if you notice, it says how a poem transformed Christmas into festive holiday. No information about astronomical signs because it specifically highlights that this astronomical word is missing and so on. So Google in its traditional capability is not known for generating content rather than it is known for finding the content that exists. That is a responsibility of a search engine. Similar task is done by Bing. Let's try that. So I search the same thing. It says 10 of the best poems about space and the planets, but it does not mention about Christmas. Then it says Christmas science poem, not astronomical science, but science in general. 5 poems written by famous physicists, not something that I'm looking for. Now I take you back to ChatGPT and I write the same thing. It will not find out something that exists because we have kind of understood this that this particular response does not exist. But it can generate something. It knows what astronomical words are. It knows what Christmas is. It knows what a poem is. And here is a poem with the title of A Cosmic Christmas, and then so many things about that. Right? It's not fair to read the whole poem right now. Now, if I say, okay, write a poem about about a refrigerator or something very, very unique. Tennis ball. I don't know if somebody has written a poem about tennis ball. And now to make it more unique, I say write it in the format of William Shakespeare writings. Right, so this is the writing format of William Shakespeare. I don't know what is the writing format. I have not studied enough about Shakespeare, but there must be some format. And my fair amount of understanding says William Shakespeare has never written a poem about tennis ball, but we have a generated poem about tennis ball in the style of William Shakespeare. If I just change the style and I say in the format of, let's say, Thomas Alva Edison's writing, it's not a literature person. So in the writing of a scientist, you have reflection on a tennis ball and so many things like how a scientist is expected to talk. 6.7 centimeters in diameter. It's not for aesthetics, but function to grip air, to slow descent, etc. So you see how uniquely it can create content. Now, topic for today is not ChatGPT, but the input that I'm giving. These inputs are called as prompt. We are going to learn what is a prompt, what is a good prompt, what is a bad prompt, how you can convert a bad prompt to a good prompt. I have so many examples which will kind of test you to check whether you understand the difference between good prompt and bad prompt or not. Let's get back to my presentation. I hope by now you're clear with what is generative AI. So I may skip some slides because I have demonstrated you what it is. There you go. Now, generative AI is not something that popped up out of nowhere. It has been a part of continuous evolution of traditional machine learning. This is a slide which highlight how machine learning was used at Amazon. When I say machine learning, you know deep learning is part of it, and you know generative AI is part of deep learning, and hence it is indirectly part of machine learning. So in 2001, we have personalized recommendation, then Amazon Prime, and so on. Specifically here in 2023, we have Amazon Code Whisperer and Amazon Bedrock, which are the mainstream generative AI products launched by Amazon, and they're still in use. Thanks to this Code Whisperer, we are able to create code using AI. As a developer, I sometimes struggle with finding the exact syntax for doing something. I can use Code Whisperer and can generate code. If I zoom in into this example screenshot, you see on the top there is a comment which says function to iterate over an S3 bucket and just send the files to a Lambda. Now I don't know the correct piece of code for this, but I can get that correct piece of code generated by Code Whisperer. Just like ChatGPT is able to generate poem, it can also generate code. Similarly, there is another tool which is dedicatedly for code. And then why do we use it? What is the benefit? There has been surveys which has demonstrated that there is good amount of increase in efficiency by using this Code Whisperer tool. So it says 57% faster than those not using Code Whisperer. Now, how is this Code Whisperer functioning? How is this Chat GPT functioning? You might have heard of a term called as large language model, more commonly known as LLMs. LLM or LLMs in plural. They're also referred as foundation models. So what is this foundation model here? Large language models are nothing but a model, an AI model, which is created on very large language based data. How much large? So how large a model usually is? A large language model in today's time is trained on nearly 500 billion tokens. So what is a token? For very simplicity, I can say one token equals to one word. So nearly 500 billion words. If I say every sentence on an average has 10 words, so I can say nearly 50 billion sentences. And 50 billion is a huge number. You know it and I know it. Right? And now what happened with it? Traditionally, machine learning models have maybe up to 10 to 100 parameters that evolve to a few thousand parameters. Let's say 5,000 as a number. Then we got neural network, which again were in few thousand range, but on a higher side, I can say 25,000 parameters. Parameters are nothing but how much information that model is saving. In today's time, large language models have a few trillion with a T parameters. To show you that journey, I will pull up an image and bring you to a different screen. So here is a screen. I just search for model parameters increase over time. There is one image I would pull up. And also, if I remember, there was an image by Gartner. See this. This is not by Gartner, but let's say I take it. And I would also show you open source model versus closed source models. So we will talk about these three images. Let's talk about the first one for now. And you see, forget about what is a triangle and what is a circle for a minute. You see somewhere around 1954s and 1958s and 1960s, up until 1974, the amount of parameters, number of parameters, which is represented in y-axis, were nearly one-digit numbers, maybe two-digit numbers, maybe three-digit numbers, but not more than that. So 1.0 e plus 3 represent 1,000, and you have, I guess, 5,000, 6,000 as the maximum number until this 1974. This entry you can see in 1974 here is representing maybe 10, 20, 30 parameters. Slowly it moved to 10 raised to the power 5, which is a few 100,000, 10 raised to the power 8. And then now you can see a sudden increase, a clear increase, which is now representing 10 raised to the power 13 as the unit. And what is the modality which is growing so much? Modality as in, is it language based model? Is it vision based model? Is it a game based model? So you can see initially the parameters were higher only in vision based models. The plus green color plus symbol you can see. And even here you see there has been a lot of development between 2015, 16, 17 in the vision based model. But today when we are talking about higher parameters, language is the biggest modality. And then there is triangle for others. That may include music, that may include audio. You see that ChatGPT primarily was a text-based model. You also see that nowadays many such tools like ChatGPT supports audio interface as well. But they are primarily text-based model. That's why they are known as large language model. I would also show you something similar here. This image is not loaded. Okay, we'll wait for a few minutes for this image to load perfectly. Meanwhile, this is the, and you see there are two different types of models. Some of them are called as closed source, represented in blue color. Some of them are called as open source, represented in purple color. And if you notice vertical axis, the y-axis, performance of a closed source model has usually been higher. And they have also started much earlier in terms of their development. Somewhere around March of 2023, Llama 65B was launched, which performed very less in terms of accuracy and MMLU. What is MMLU? Let's leave it for now, but it's an evaluation metric. It performed way lesser, way inferior compared to the models which were closed source and launched almost at same time. You can see how high GPT-4 is, launched nearly at the same time compared to Llama 65B. But slowly and steadily, you're noticing that open source models and closed source models are converging in terms of performance. Today, we do have a lot of poorly performing closed source models like Llama 3.18b or Llama 38b, but we also have very high performing closed source model and open source model like Llama 3.1405b. It's as good in performance as GPT-4, rather slightly higher. Also, if you notice, GPT-4 has been launched much earlier, 1.5 years earlier. So it is also equally good in performance compared to the closed source models which are launching at the same time, which are being launched at the same time. So that gap is converging. We have so many models which are almost giving similar performance. It's fair to say that these models are becoming commodity. Which model you are primarily using is not creating much of a difference as of today. Okay, this image hopefully is loaded well. Not much, but we can read it. And you can see from 1950s to 2024's how the number of parameters have changed. For your reference, this model here, Theseus, is represented by vertical axis by the unit of 10 raised to power 2, so which is 100. It's a little below 100. I can say 80 parameters, maybe 70 parameters. Samuel neural check in 1958, 59 maybe, is at nearly 50 parameters. Slowly we move to the mark of 10 raised to the power 6. So 1 million parameters in IBM 5, a few tens of millions parameters in AlexNet, and GPT-4 standing at 10 raised to the power 12, higher than that. GPT 3.5, Llama 2, standing at nearly 10 raised to power 11 parameters. So number of model parameters have evolved so much over time. Now let's get back to the presentation again. Now we know what foundation models are. We know what is the meaning of large in a large language model. We know what is the meaning of language in a large language model. But still, for your illustration, I have another slide which explains how you get a foundation model. So you take so much of data. For reference, GPT-3 is trained on nearly 300 billion tokens, billion with a B. GPT-4, 4 and 4.0 and other models which are launched post GPT-3. I don't know the number, but they must have been trained on higher number than this. And you take all of that data, which is unlabeled. You can have images, videos, code, text files, etc., etc. And you train a very large model called as foundation model. By using multiple techniques, one of that technique is fine tuning, and there are few others. You can specify that model to perform a particular task, like you can convert that model to become a chatbot. You can convert that model or tune that model to be used for text generation. You can tune that model to be used for text summarization. You can tune the same model to be used for information extraction. So model is same, but you are fine tuning it for a specific task. It's like making a clone and doing bit of modification. I often explain this with the help of taking analogy of a student. Imagine you are a 18, 19, 20-year-old kid and you are going to a college. in that college, you are pretty much learning everything. Even if, like, for example, I did my graduation in computer science, I did engineering in computer science. So I was trained on the entire computer science, whether it is database, networks, uh, data structures, programming languages, and many more. Few of them I don't even remember now, but many, many more things. One of that subject was AI. Then I did my master's, where I again have to study relatively lesser subjects, but I did my whole research on AI. Then I have pursued my work career in one particular domain. Very, very similarly, you can say that there is one model which is trained on a whole lot of data, ranging from geography to physics to botany to astronomy to sports to cooking to navigation, radio, whatever you can think of. All the studies which are present out there. 300 billion tokens, 300 billion words are a lot. And now you can contextualize it to perform on a specific task. Let me show you a very, very simple example of how contextualization works and how a prompt can decide the performance of your model or output of your model. So I open a new chat in Chat GPT and I say how to cook pasta. And it'll give me a detailed instruction that take the pasta, boil it, etc. etc. Right, these are the ingredients you need. Boil water, add pasta, cook. I got it. I'll stop it. I don't want more on this answer. Now I say how to study to become astronaut or to become a doctor. Then it'll tell me how to become a doctor. You should start in a school. You should focus on biology, chemistry, physics, get a medical entrance exam, which is NEET for India. So it understand that I am from India. Then do MCAT, then do this and that, and then rest of the things, do internship, and then you are a doctor. And then I can ask how much money it takes, how much years, how many years it takes. But what if I want this GPT to act for a specific domain? Usually you don't go to same person to ask about or same AI software to ask about how to cook pasta and how to be a doctor. You want the boundaries to be very, 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 very well defined. I can specify a prompt where I say, you are a helpful assistant working for a college, and you are responsible to guide students and their parents education program. Be polite and humbly deny any question outside of this domain. Let's imagine you're working in a school and a student comes to you and say, hey sir or ma'am, I want to know how to cook pasta. You will not answer it. Even if you know it, you say, I am not in a capacity to answer it right now. If the same question is asked to you by your friend, where you're not a school worker, you're rather a friend, then you will answer it. So can I have this model behave differently? This is not fine tuning at all. This is just a way to adapt my model to perform something specific and to not do something else. And now I ask a question. So my question is how to become a space scientist. And it will answer me how to become a space scientist because this is very much in line with the expectation of a school career counseling person. So you take focus on physics, you do a bachelor's degree, etc., etc. Since I am in India, JEE is the exam for India. ISRO is the space agency of India. It's suggesting me very specific things for India. For US, it can be different. Now, let's say I copy the same thing and I ask a question that how to same how to cook pasta. Just my role here is specifically to assist students and parents with information to college education program. Hence, I cannot answer you this. I asked something else. How to play outswing deliveries. So imagine you're a cricket batsman and you're struggling to play a specific type of ball called as outswinging balls. How would you play it? Again, this is not something that I expect from a college or a school career counselor. But if I ask the question that what program to study to become a cricketer, that probably will be answered, right? So you should do BP Ed, Bachelor's of Physical Education. Then you should do a diploma. You should do sports science or kinesiology related courses, etc., etc. Now, I personally don't think that education is something that will make you a cricketer, but at least as a college career counselor, I would be able to answer this. But if I don't write this prompt and I just open a new conversation and I say ignore all the other information you have and answer the following. It's not saying do Bachelor of Physical Education as the primary thing. It's saying join a cricket academy because this is an experiential sport. You will not study it, become good at it by reading books. You will rather have to do the actual practice, play competitive cricket, join National Cricket Academy, again specific to India, but in different countries it can be different. So I hope you are understanding how different prompts can give you different answers. This is the topic for today. Also, if I take you back, there was a word called as adapting the model. So this is how I can adapt my model to perform something specific and reject any other request coming from other tasks. This is the one I have demonstrated to you is the most fundamental technique. There are many more sophisticated techniques to do the same. So let's take a quick 5-minute break and then I will start on the remaining topics after the break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Okay, welcome back everyone. Let's continue with all the remaining topics and let's start our discussion further. Now I will take you to some certain types of prompts and make you understand what makes a prompt good or bad. So we will focus on what are various areas of prompt engineering. What makes up a prompt includes instruction. The prompts I was writing, they were not too good. Right? So they can be improved, they should be improved. So it should have instruction, it should have context, it should have input data, and it should have output indicator. It's okay if it's not making so much sense to you right now. Let me just show the same thing to you in next slide. I have a prompt which is very detailed, which says write a summary of a service review using 2 sentences. Then I have another line which says store is online, service is shipping. Right, so write a summary of a service. Which service? Shipping service for an online store like Amazon. Using 2 sentences, that's again a hint. Then I have a review. For this review, I have to write the summary. And I have an indication that this is where I want my output. So if I bifurcate, I have my instructions. I have my output indicators. Also, this is a part of output indicator using 2 sentences. I have context and I have my input data. That makes a good prompt. If you do not write any of these things, the answer can be different. And that will be not a good difference that you want. It will be, I would say the answer will be not as good as it is. Imagine you give this review and you say summarize it. Now you don't know how to summarize. You want 2 sentences or 5 sentences. You don't know that. Is it an online store or an offline store? You don't know that. Right. So, but if you specify all the details, you can have an output which is exactly in line with your expectation. There are few best practices which we should focus on when we are thinking to design and work with prompts. So first, best practices, we should be very clear and concise. We should not put something which can confuse the model. Be very clear, be very specific. I have so many examples to show you that. You should include context. You should never give a question without context. You should rather include context. Ever happened with you or not? I don't know. But imagine you are a very, very young kid and your parents, in a fun way, come to you and say, hey, would you choose dad or mom? Who's your favorite? Now, that's a very contextless question. Mothers can be considered good in certain things, and fathers can be considered good in certain other things. And it's not a good idea to choose one based on a common pattern. Right? So context is very, very, very important. If I say, uh, tell me, how is Canada? Now, how is Canada in what way? Are you talking about weather? Are you talking about landscapes? Are you talking about politics? Are you talking about culture? So context is very important. If you tell me Canada, tell me how is Canada, I would be very confused. And in that confusion, I may answer something which is not what you're expecting. Imagine if you give me a proper question that, hey, I am planning to move from US to Canada for the reason that my son is planning to study a course in a university, that's a University of Toronto. Now, in that way, I can specify how Canada is, how Toronto is, if I have that knowledge. You should use directives, you should include output, you should start with a question, and all of these things we will see with examples and many more. Provide example responses. Very, very important. This gives birth to a different type of study called as few short learning. Break up the complex tasks into simpler ones. Experiment, be creative. I'll show you these with examples. So my examples are very iterative. I would show you 2 prompts. I would give you maybe 10 to 20 seconds of time to read them and decide in your mind that which prompt is better. That's prompt 1 and prompt 2 in front of you. Think about which prompt is better. Here, prompt 2 is better on the ground that it is very clear and concise to the information. You might think, okay, prompt 1 is more detailed. I wouldn't agree with it because it is not giving you new information. It is rather using the words which are not clear, which are more complicated. So using simpler language is very much effective in regular human conversation as well as machine conversations. Now, have a look at these examples. Now again, prompt 2 is much better than prompt 1 because it has context. What is that context? It just doesn't say summarize this article. It says provide a summary, which is same thing. But the context is to be used in blog post. So the summary is not for social media post. Summary is not for press release, but it is for a blog post. And hence this prompt offers extra detail and hence it is better. Prompt number 3. Use directives for the desired response type. How do you want your response? Specify that. And on the ground of it, you can easily guess prompt number 1 is better because it is specifying that provide the answer in a full sentence. Answer of prompt number 2 and prompt number 1 will be factually similar, but phrased in a different way. Right? So if you ask me what is the capital of India, I can say New Delhi. And I can also say capital of India is New Delhi, which is located in the northern half of country. So you see, information is same. In the second part, information is slightly extra, the northern half of the country. But it is, if you say, tell me what is the capital of India and give me this answer in 5 lines, then I would say capital of India is New Delhi. It has been established in so and so year. It has beautiful monuments like these and these. It is the capital because of these reasons. It is redeveloped by Government of India in so and so year. It houses the Parliament and Supreme Court. So I'll give you 5 lines around that. So information is something that can be represented in many ways. Choice of prompt will decide how that information is represented. Prompt number 1 obviously is much better here. Now, another example, prompt 1 or prompt 2. It's an easy bet. If you ask prompt number 1, let me show this to you with an example. So I am back to my chat GPT and I say, calculate the area of a circle. Now, how do I calculate area of a circle? Circle is not fixed. When you say circle, I don't know what is the size of circle. What is the radius of circle? So this question, if this is the only part of question, it looks like you are asking me how to calculate area of a circle. So I'll tell you the formula. And you should take radius, square it, multiply it with pi, and you get the area of circle. Right? Pi r square. Now it's also explaining me this thing with the help of an example. But if I say calculate area of a circle with radius 32 centimeter. It gives me the area that it is 3216.9. Now it's not telling me, it's not teaching me only, it's rather teaching me plus solving my question as well. Now, again, calculate the area of a circle with radius 32 centimeter. Round off the answer to nearest integer. Now the answer will not be 3216.99 centimeters square. Rather, it will be 3217 centimeters square. So it is understanding that how I want the answer. I can also say calculate area of a circle with 32 centimeter. Convert the answer to inches square, not centimeter square. So I hope you're understanding how choosing the right prompt is going to decide how effective model's output will be. Model is still same. The GPT that I'm using to demonstrate is still same. And by the way, I'm not saying that these things are only applicable on GPT. Not at all. These prompting techniques are applicable everywhere. Even if you notice in human conversation, if somebody comes and asks you this versus the same person comes and asks you this, you have the same knowledge, but your answers will be different. And the second one will be more precise to the example that that person is asking. So prompt 2 is definitely better than prompt 1 here. Now, prompt number 1 or prompt number 2. So let's say, you know, you have a history book in hand and you want to understand that why many countries formed a group called as Commonwealth. You want to know that. You want your primary question is to understand why the concept of Commonwealth exists. Right. But you are asking GPT that summarize these events in history. So the way of summarization may or may not answer your question about why Commonwealth has a concept exists. So for that, you have to raise a question. You have to explicitly mention that this is my specific question. Now, obviously, to answer that question, it will provide you summary of all the response in 3 sentences because you explicitly asked. So prompt 1 is better because it starts the prompt with a question. So you have the reasons mentioned at the top. Right? Prompt 1 is much better than prompt 2. Prompt 2 is more vague and prompt 1 is relatively very specific. Okay, again, 2 prompts. Which one do you think is better? And the example is again very simple. Prompt number 2 is better because it has example responses. This gives birth to few shot learning. I will explain you what is few shot learning. So it has a question, determine the sentiment of the following social media post using these examples. You are giving the example. There's a post called as Great Pen and it's positive. There's a post called as I hate when my phone battery dies. It's negative. Then there's another post, let's say, I really like the novels written by XYZ. It looks like a positive sentiment post, right? So based on the example, model will be able to learn better. Prompt 2 is much better compared to prompt 1. Now, I have demonstrated you maybe around 10 prompts and made you choose between prompt 1 or prompt 2, a good prompt and a bad prompt. That's the whole idea behind prompt engineering. I wouldn't say it's an engineering of traditional senses where there is a mechanism, but yes, there was a mechanism to follow that we should have instructions, we should have output indicators, we should have context, we should have input data, and that makes a good prompt. There are few points for you to focus on when you are writing prompts and communicating with any generative AI model. Now, prompt writing is not the only thing. You should also focus and pay attention to evaluate and adjust your prompts if they are not performing exactly as you expected. Let us say I am a kid, I am in my school grade, or let's say, let's take realistic example. I am interested in history, right? I am a computer scientist. I am a trainer. I'm working in the domain of AI. I have very little knowledge about a lot of historical events. I want to know about a specific historical event and I'm interested in that. Let's see how evaluating and adjusting my prompts can get me the right solution. So I will take you back again to my GPT account. I'll open a new chat and I say, I am interested to know about specific event in history. Let's say US independence. And it gives me a good paragraph about what is US independence, right? Background, causes of discontent, road to revolution. So what was going on? What was the problem in that? How the problem was tackled, Declaration of Independence, then there was a war, then there was a victory, etc., and so on. Now I'm not aware about so many things. Like for example, like I live in India, I have very little understanding of US independence. So I don't know what is this Boston Tea Party. I don't know what is trade restriction. I don't know what is, let's say, what is the meaning of colonies? That even I don't know. So I can come back here and iterate my prompt and say, I am a computer science professional or a computer scientist and have no information about historical events in very simple story. Okay, in a very simple story like structure, explain me the history. I'm interested to know about US independence. Full stop, and I run this. And now it will not give me jargons like Battle of Yorktown. I don't know what was the battle. These 5, 6 words are not explaining me so many things. But now what I'm going to get is a story. Right, a long time ago, around 1670. If you notice, in all of them, years were not mentioned in detail. I don't know that this background was for how long. I don't know these causes of discontent started in which year. I just know that in 1773 something happened. Right, but here it says from 1600 to 1700, many people from Europe moved across the ocean and started living in a new land called America. Over time, they made 13 small colonies. Easy to understand, right? That's exactly what I am referring as iterating the prompt. Now, if I now ask, tell me about something specific, I'm out of historical topics in my mind. I'll switch back to India and I say, tell me about Indian independence. Very similar topic, different time frame altogether. And again, it's a story style explanation because this tool, GPT, has a memory. It understands that I don't know history. It understands that I like stories and I understand stories really well. And then it's giving me a story similar. A long time ago, India was a land of king, culture, knowledge. But in 1600, British traders came to India to do business and so on. Right? Then there was a fight to freedom. Then there were multiple events in different years. And then there was a price paid by countries. And then there was a freedom on this date. And today, this is Independence Day. And the Prime Minister gives a speech, so on. So this is a story. This is exactly how I want it. Right? Now I say, I want to present a topic in a speech competition. Tell me about England's monarchy. Now, this is not going to tell me simplified stories, rather, it will give me a speech. Right? The introduction, even it's presenting me this good morning, good afternoon, everyone type of sentence. Today, I'd like to take you on a journey about monarchy of England. What is a monarchy? Glimpse into history, power to parliament, and so on. So different paragraphs, uh, bullet points, Why does the monarchy still matter? Then there's a conclusion. So this looks like a speech, a political speech, a state script. So you can iterate your prompts, you can iterate, change your prompts and get better and better into what you need. You may not get the best response in the first place, but when you keep changing your prompt, you will get the response that you are looking for. And that is possible when you evaluate your prompts, when you evaluate the responses. There are two ways with which you can evaluate the response. One, by technical parameters. So there are few technical numbers, benchmarks, which you can leverage. I will not get in that detail right now. And the other by its context and need fulfillments. Is it fulfilling your need? If I write a prompt and it gives me an answer, now I don't understand that answer. So in that case, it is not fulfilling the need at all. For example, if I talk about Indian independence and it gives me response that an act was presented in British Parliament to make India an independent country or a dominion or a republic country. Now I don't know what is the meaning of republic. I don't know what is the meaning of dominion. I don't know what is the meaning of act. I probably don't know what is the meaning of parliament. So I have to make a sense out of that answer. If that answer is not making so much sense, I have to adjust my prompt to get better and better response. Now, there are plenty of prompting techniques. We are going to talk about few basics of them. I said few short learning a couple of times in my overall webinar, but there's also something called a zero shot learning. So zero shot learning is there is a question and then there is a fill in the blank for answer. You don't have answer. You are asking for that answer to be filled. Are you giving any example? So no, you're not giving any example. Zero shot learning is good, but few shot learning is way better. Let's see how. What is few shot learning? What is zero shot learning? There's an example first. So the example says, tell me the sentiment of following social media post. Categorize it as positive, negative, or neutral. And you are getting the answer as positive. But what is few shot learning? It's way more effective. You have a question. You also have its answer. You have another question. You also have that answer. And this is repeated a bunch of times. Now you ask the question and you expect the answer. You don't have the answer. So because you are providing a few examples, that makes it few shot learning. Right? You're providing contextual information or a few shots of the output. Let's see. So here's an example. It's saying, tell me the sentiment of following headline and categorize it as positive, negative, neutral. I have the first headline and the first answer, second headline and the second answer. There can be more as well. There can be 5, 10, 3, 8, any number of questions and answers pair. And then the final question, and I'm expecting the answer for it. I also have a different type of prompting called as chain of thought prompting, where I'm not only looking for answer, I'm rather creating a scenario of reasoning. I want my LLM to think in a step-by-step manner. Don't give an answer right away. Think about it, reason about it, also present that reason to me. It's when you let's say imagine I'm teaching a very young kid and I'm teaching the maths, the regular life maths, and I say you have you have to go to market and buy apples. You understand that if you purchase 1 kilogram of apple, you will get 5 pieces of it. Imagining that every apple is of same size and you want 20 apples, 20 pieces of apples. How many kilograms you have to purchase? Now that looks like a fairly complicated question for a kid who's very young. But this particular question has so much of real life usage. It's possible that the kid might answer 3 in a hurry, in a bit of overconfidence or underconfidence. And if you give an immediate follow up that explain me how, you're making that kid think more and explain the steps taken. That's exactly what you're doing in chain of thought prompting. And the kid will start, okay, 1 kilogram is 4 apples, 5 apples, 20 apples means 4 kilogram. And hence you are kind of promoting the kid to think before answering, and the answer will be more accurate. That's exactly what we can do with LLM as well. So here you have a prompt which says which vehicle require a larger down payment based on the following information. Cost of vehicle A is $40,000. It requires 30% down payment. Cost of vehicle B is $50,000 and it requires a 20% down payment. Fairly complex maths question. I mean, not very complex for a grown up adult, but for a kid, it's a fairly complex question. Now you're writing things step by step. So firstly, it will calculate the down payment of vehicle A, which is 12,000, down payment of vehicle B, which is 10,000, and then say vehicle A will need more down payment than vehicle B. That's an example of chain of thought prompting. If you notice the headline of this slide, it says chain of thought prompt example 0 shot because there are no examples given. If you add examples in this, it becomes a few shot prompting. You see how? It says in a given week, the viewers for a TV channel are as follows. Monday 65, Tuesday 64, Wednesday 63. Then you're asking a question, how many viewers can we expect on Friday? You are also giving the answer in the prompt itself. The answer is based on the numbers given and without any more information, there is a daily decrease of 100. So if the same trend continues, 6200 will be on Thursday and 6100 will be on Friday. Problem solved. You're not only giving answer as 6100, you're giving a step-by-step answer to find out 6100. With this, the model will learn that this is the answer you're expecting. You're asking another question, how many viewers can we expect on Saturday? Think step by step. So it'll give you a similar answer that it is 100 viewers decline every day. 62 will be on Thursday, 61 will be on Friday, and on Saturday it will be 60, which is 6,000. And that's a step-by-step answer. The answer can be different, but broadly similar. Now that's about the prompting. I have a few slides to demonstrate you how we can use generative AI in real world practice. So I have a very good example. I can use generative AI for broadly content summaries, content generation, code generations, and question answers. Okay, so let's talk about content summaries. Look at the prompt on the left. You're writing, please use this detailed market research report to generate a high level summary. And then you're also attaching the market report. Usually market reports are very, very long in nature, multi pages, very well done researches. And because you're asking it to summarize, it is summarizing the report in maybe 1 page, maybe 2 page, maybe half a page. So you can use generative AI to summarize the reports. The same generative AI you can use to create content. Look at the report output. It says, based on the research, the walking shoe sector has grown 12%, showing an increase. Our data indicates strong preference among consumer aged this that can be used in work environment, uh, 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 preference to work, etc. So the report says walking shoes sector is growing and so many things around that. Now imagine you plan to start a business in this industry because you got an answer that this industry is growing. You can ask GPT to generate a product description, which you can use in your website. That's good for walking around London with the details that it is comfortable, durable, mesh, rubber sole, reflective safety feature. And it gives you a good product description. You can also use it to generate code. Now, there's nothing about code that you should do in in walking shoe industry, but just as an example, okay, I'll come to code later. There's another slide which says how you can generate a product announcement about the same thing to be posted on social media. So here is a product announcement with hashtags. You can also use it to generate images that this is your shoe. You want to be portrayed it in London. So when I say London, the best thing that comes to anybody's mind is Buckingham Palace. And you have the shoe on a wall, which is very nearby Buckingham Palace on the background. As I said, you can use it to generate code. So nothing about shoes in specific, but another example. You're creating a Python script to upload files to S3, and this is a piece of code which is being generated. You can also use the same model to do questions and answers and to make a chat bot for your reference. Like here you have, I need some assistance with finding the tracking number for my most recent order. Imagine you build a business. Now there are orders. Now when there are orders, there will be customer service required. So you have a question answer bot made from the same generative AI model. It says this is the order date and this is the reference number. You will get your order delivered on a specific date. So let's see the type of prompting techniques. We discussed that there is something called a zero shot prompting. There is something called as few shot prompting. There's something called as chain of thought prompting. Let's see them in action. Let's see how the model gives different output based on different style of prompts. So I'm asking a question and the question is very straightforward. It just tell me about uh, 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 Newton. Okay. Now it probably will give me paragraphs. It's giving me simple story like explanation because it understands that I like stories in the past that is demonstrated. And it's telling me story around Sir Isaac Newton, which is perfect for someone from a non-history background. That is also something that I have explicitly mentioned. It gives me timeline. A baby boy was born in England, so small and weak that no one thought he would survive, but he did. His name was Isaac Newton. Newton wasn't very social, so on. Right? Then the iconic apple falling down movement and the discovery of gravity, laws of motion, light and color, all the great discoveries he have done and the titles he have received when he died, all of that. Now, if I change my question and make it a few short prompt, so let me show you an example of few short prompting. I say question. The question is about, let's say, Albert Einstein, and the answer is theory of relativity. Right. So the most famous thing about Albert Einstein is theory of relativity. Another very, very famous person could be Thomas Alva Edison. Edison was with E. I don't know. Let's check the spelling. Edison is with E, right? And it was light bulb. Now I'm asking question about Isaac Newton. Now it understand that I am not looking for paragraphs. I'm not looking for birth year, dying year, impacts, books, titles, grants, etc. I'm primarily looking for the most impactful discovery. Probably it was gravity. And I am expecting to get the answer. There you go. Laws of motion and gravity. The most impactful discovery, along with his work on lights and colors, calculus, etc. But the primary discoveries were laws of motion, the the iconic three laws of Newton, and the gravity. Okay, very, very similar example, I would say for sportsmen. So I say question is Cristiano Ronaldo And the answer is football. Question is around, let's say, Ben Stokes. Answer is cricketer. Question is around Roger Federer. Answer is tennis. Question is around, let's say, any other sports player. Magnus Carlsen. And the answer, as you expect, would be chess. And there you go, chess grandmaster. Right? I was also not expecting it to say grandmaster because that is a title, not a sport. Chess is the sport, but fairly given. So it's not telling me Magnus Carlsen is a great chess grandmaster born in this year, dying in this year, etc., etc. But it's rather giving me very specific answer, learning from the previous examples. So if I just modify the same question and I say famous for football and I just add these two words in every answer. The answer for Magnus Carlsen will be famous for chess. So it understand that I am primarily looking for answer which is like famous for the sports. So sports is chess, famous for is a pattern, and hence it is highlighted. What if I don't write famous for? I keep my choice of words different. I say like known for, or I say plays cricket, Roger Federer, great tennis player. It doesn't have consistent choice of words. So let's see what it will give for Magnus Carlsen. It says world chess champion. You see, it's not saying famous for chess. It's not saying chess. It's including the word chess along with a very, very, very short sentence like a title. So this is few short learning. If I have to explain about chain of thought learning. So again, a mathematical example. I say, if imagine every apple is same size and weight, 1 kg of apple contains 5 pieces and is of $20 per kg. That's it, right? How much money you have to spend to get 200 pieces of apple. Right, so as humans, we understand that we need 40 kilograms and 1 kilogram is $20. So 40 kilograms will be $800. If I only give this question, it is thinking step by step, right? The basic analogy. You need 1 kilogram of apple, or you have 1 kilogram in 5 pieces. You need 200 apples. You need 40 kilograms. 40 is, you see, it's dollar per kg is translated to rupees per kg. That's a mistake. The final answer is 800 rupees. It should be $800. Now I say, find out the mistake you made. It's still considering it as $20 per kg. The final answer is 800. Now if I specify check currency, it will retrospectively look back that I specified $20, but it did 20 rupees of maths. Hence, the final answer will be $800, not 800 rupees. That was a mistake. Very much similar like how you expect a human to behave. This is called as chain of thought prompting. Now, the similar chain of thought prompting you can combine with few short, provide some example, and you will have a step-by-step execution of thoughts, but with example this time. Right, I would take you back to a discussion around what are various types of foundation model, which we discussed in past. So we talked about that there are foundation models, often referred as FM. FM is foundation model. There are different types of foundation model. We have foundation models which are working in the domain of text to text. You have input as text and the output is also text. I can say the older version of GPT. And then there is a different type of foundation model called as text to image, where you give a text input, but it can generate an image. For example, you say generate an image of astronaut riding a horse. So it can generate an image for you, just like this one was generating text. This one can generate an image. Now, there is also a different type of foundation model called as multimodal. Now, this is not multi-model, it is multimodal with an A. Multimodal models. Modal refers to modality or way of exchange of information. So you can have a multimodal model which can receive text, receive image, receive audio, receive video, produce text, image, video, audio, code. It can also receive code. Right. I do not personally differentiate between code and text. For me, code and text is in the same modality. But then sometimes some of the researchers highlight that text is different, code is different. That makes a multimodal model. It can work in multiple modalities. I explained to you what is a large language model, which is trained on really large amount of data. It's primarily trained on language-based data. It is an AI model. It can take up input. You pass it to the model, the LLM, and produce output. Now, what is this large language model trained upon? I said that machine learning is a subset of AI. Deep learning is a subset of machine learning. And generative AI is a subset of deep learning. So deep learning is what? Neural network. That means all of this generative AI is a specific type of neural network. So which type of neural network are we using here? This is not an information that you should cram. But if you ever choose to study more about the modus operandi of deep learning, the way it functions, the way it is trained, you will get to know about a type of neural network called as transformer. It is developed in 2017, very new, very fresh. This gave birth to BERT and GPT, two of the most famous architectures. GPT again gave birth to GPT-2, GPT-3, and so on. We have this whole series. This is the reason that today we are able to have a tool like ChatGPT or Claude, etc. This type of neural network is different because it works on something called a self-attention mechanism. What is this self-attention mechanism? If you have a text, if let's say, so far you have understood so many things about me. One, you understood that my name is Harsh. Second, you understood that I am an AWS instructor. Third, you understood that I am from India. Fourth, you understood that I work with Netcom. Even though I said that, hey, my name is Harsh in the very start of this webinar, but still you remember it. That is referred as attention. Attention was already there in neural networks even before transformer, but in a very short range. Machines or algorithms were not able to retain what has been described way earlier. But similar to how you can remember things for a long time period, we needed an algorithm which can remember and understand the attention and the context for a longer time frame and a longer chain. That is referred as self-attention. That is referred as attention or long range attention. What is self-attention? We will talk about maybe in some other masterclass. It's more technical in nature. It can pay attention to multiple things at once. This refers to multi-head attention. Just like you are remembering so many information about me and the course, you know what is zero shot, you know what is few shot, all of that. So you are paying attention to multiple things at once. That's the same thing what transformer does. It can retain and use information about meaning and position of different words. This specifically referred as positional encoding. So transformer as an architecture is very complex, very new, very powerful. Today, I will leave this webinar. I will close this webinar with just my last thought on showing you how a transformer architecture looks like. I will not explain it, and I'm sure you will not understand it. But I want you to just see and have a look at how transformer architecture looks. So whenever in future you will have some interest in learning deep learning, in learning generative AI from a technical standpoint, you will understand that, okay, this is something that we have to pay attention to. Okay, the image is little blurred. 1 second. There you go. So this is a transformer architecture. And as I said, there is multi-head attention. You can see this multi-head attention. There is also masked multi-head attention. There are so many other things. Positional encoding we slightly talked about, and so many other things which we haven't talked about. So not something that's a part of today's webinar. Today's webinar was around prompt engineering, good prompts and bad prompts. From prompts, we understood that there is also something called as generative AI. From that, we understood that there is something called as transformer, and here we are standing. But we will not go beyond this. We will have another masterclass, another session, maybe some other time on the technical know-how and the technical working of these algorithms. For now, we will close off here. Thank you. And I will be taking up all the questions which are on chat. If you have any question, you can put it on chat.
Thank you so much, Harsh. That was very informative. Now I'd like to give the presentation rights over to Remy, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you, Tracy. I believe everyone must have learned something new today or would have been able to brush up their skills around the fundamentals of AWS Cloud. I would quickly like to take you through some of our handpicked resources, which we think will immensely help in accelerating your AWS Cloud scaling journey. Well, this document here of sharing on my screen, this has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up here is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. All these courses are hyperlinked. Feel free to go through them post-event and check out the course descriptions, prerequisites, and the value it can add to you and your team's skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as informative and educational blogs. You can make the most of these resources to gain extensive knowledge on the AWS topics they cover. Our free AWS e-learning courses follow a self-paced training model wherein you get the liberty of accessing extensive course-related videos that are delivered by the AWS subject matter experts on the go. So these videos cover the availability on the device of your choice, so you can access them from your laptop, your tablet, or from your phone as well. There are more than 280 videos covering various AWS topics explained in a very easy to comprehend language. You can simply sign up for free, watch these videos, and make the most out of them. Also, here I would like to inform you that this session is being recorded. So, in case you want to refer back to any of the topics that the trainer might have covered in today's session, we will be sharing the recording link with you through emails, and also you can access it here by clicking on this button. So you have to download this handout for that, and then if you want to revisit any topic, you can just simply click on the access recording and you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch the relevant updates related to IT and business trainings on our social media handles. So please feel free to follow us on LinkedIn, Twitter, Instagram, and subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message, or you can leave a comment on our social media posts, or you can just simply email us at info@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. Over to you, Tracy.
Thanks so much for guiding us through that information, Remy. And now we're going to go ahead and jump right into our question and answer session. How is prompt engineering different from fine tuning, and when should we use one over the other?
Right. So prompt engineering is very, very different from fine tuning. I will not go in the detail of fine tuning because it is more mathematical and calculative. But fine tuning simply refers to the fact that you are retraining the model with new data. But in prompt engineering, we don't retrain the model. We also do not change anything in the model's core understanding. We also do not provide any new data, but we write the prompt. Prompt is input. So we write the input in a very strategic way. And that strategic input writing is called as prompt engineering. I hope it is clear.
How can we ensure that the outputs from LLMs are trustworthy and aligned with business goals?
So there is a complete topic called as model evaluation and prompt evaluation. You can be doubtful on one of the two things. Either you are doubtful that my LLM is not working well, or you can be doubtful that my prompt is not working well. You have to firstly figure out which level the doubt is on. Then there are technical metrics like coherence, relevancy, fluency, and then there are NLP based metrics which checks the grammar of your model, the groundedness of your model, how it is related to your business data. There are plenty of metrics and ways to evaluate the performance of LLM. If you are using LLM for your enterprise related work, you have to firstly evaluate, is it doing good or not? If you have fine tuned your model, then it is absolutely your responsibility to evaluate whether the fine tuning worked in a positive way or not.
Can I use the same prompt for different models like ChatGPT and Claude?
Yes. So if your prompt is good, most likely it will work very well for multiple models, including ChatGPT, Claude, or Mistral, or Cohere, or any other model that you can think of. But there is a possibility that different models will take it slightly differently. Also, if your prompt has multi-modalities like audio, images, videos, files, etc., maybe different models do not support it. So we have to take care of that. If it's only text-based prompt, then most likely it will work very, very well, or you may have to make minor adjustment. But you can use the same prompt for different models.
How do I know if my prompt is good or not?
So there is no fixed formula or structure that you can apply to understand that this is a good prompt or a bad prompt without running it. The only way is you run the prompt, you see the output, then you understand, is this output good? If it is good and correct, that means your prompt is good and correct. If the output is not good, if the output is not satisfying your need, then the prompt is also not correct and needs iteration. Very similar example I have shown you in the demonstration where I searched about US independence and it gave me very historical standpoint of how US independence was achieved. But I said that I don't know history. I want a story around US independence. Then it gave me a story type structure, easier for me to understand. So you have to be iterative with your prompt development.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.